Alright, so this is what I got proposed in AutoCAD. Drawing this right here, and then drawing that arc there. And I'll be using Earth-centered, Earth-fixed coordinates. I'll leave a little bit of information in the description, so you can read up on it. It's pretty neat. It makes a shape. Grab some coordinates and lat and long, convert it to X, Y, Z in 3-dimensional, and you can make a shape of something. So that's what we're after. So you can kind of, let me go through where I get to my drawing, like benchmarks. Let's go here. It's like, how do I come up with the, benchmarks or the XYZ coordinates? Let's see if any of these have a ellipsoid height. Alright. So, on this control data sheet here, you got the ortho height, which is the ground. So around in Kansas City, we're around 900 to 1,000 feet. Meters. And then you get your XYZ values. You got your geoid height and your ellipsoid. Normally, if you didn't have your ellipsoid height, then you would just take this minus this. So that's why that 274 is subtracted basically from the geoid. So a lot of the data sheets, like on here, that they just don't have, see 9 and 9, they just don't have it. So, and then I have this program that put my lat and long in there and the ellipsoid height, and I say convert, and it puts out the numbers, and then I create a text file like this. And so this is it. So this is what I'm doing, and see how it goes. So here it is. Here's the globe. First off, I'll show you the radius, or what I used. So everything's in meters, just to make it, because everything they use is meters. So convert meters to feet. So that radius. Radius. Or miles. Am I saying feet? Miles. So 3958 for the radius. Alright. So let me just turn on. So this is what I got. I drew an arc on this one because it's real long. On these little short ones, you don't necessarily need to draw the arc. It's too short. This is like 500, over 500 miles. And this one down here, I drew the arc. Fit pretty nicely. So we'll get into some of that. Okay, so here's Chicago to Washington, and then Liberty 1 to the Empire State Building. And so, just so you know, I didn't place these points by hand or anything. It's based on a coordinate system. So I'll just delete this text file that I just showed you and re-import it back in. So now they're all gone. So there's no points. Well, that's that line. I create a line, so when I do that, I create 2 points, one above it, so I have a straight line to give me this all the way down to the equator. And then I draw a line straight down to the equator, and then I do my triangle. And then I draw one to the north. So that's why you see them. That's why they use this for various things, satellites. So alright. So I'm gonna re-import them points back in. Next. So that's the points that I had. PNEZD. I hit next. So here's all my values. Next, and then finished. And then they're back where they are. So I don't. Is what's cool about this. Normally in surveying, you don't get a drawing like this. It's usually, just a top view, and that's it. I guess I'll show the distances first. So, on this one I drew the arc, which are the radius on that, or the arc length. Not bad. Could wrote that too. So I got 595.6. So 596. And just so you know, it's Sears Tower. We can tell us, yeah, it's the Willis Tower. So then to the Washington Monument. And then to Liberty One. Philadelphia, and then to the Empire State Building, which is right here. So you can see all the points. And now from 5 to 9. So I had properties and get this measurement. I print screen that so you can see what that actually says. So it says 596. And that's what I measured on that one. We don't need that no more. We don't need that no more. So then let's measure these little short ones. So from Philadelphia, or from Washington Monument to Philadelphia, I got 124 miles. I don't know if you can see that, but maybe when I edit it, I'll zoom in. So in Google Earth, so from 9 to 3 properties, and I measured 124. And I measured 123.9. So that's perfect. You probably can't see that, so I'll do a print screen. Edit, paste. 124. And then from Liberty One to the Empire State Building, I got 83 miles. So Google, so going from 3 to 7, measurement, so it's 83.1, which I got 83.1 here too. So do another print screen. $83.1. Alright, now let's do the this is this one here. You can barely, pretty pixelated. So whatever that city is to this city, South America, Australia, or somewhere over there. And I don't even know what that meant. It's 80. Well, you know, I'd have to see. Convert kilometers to miles. 86. Well, we know it's kilometers. 5,343. It's longer than that. That's not gonna work. So that's why I got that there, or did that one. So let's measure that. It's kind of a little different. I'm working down below the equator. I'm not used to it. It's like reversed. So that's my chord. And here's my arc. And so I measured radius or arc length. I'll keep saying my arc length. I need meters to miles. So I got 5,385. So hold on. That's what I got. This thing. 80, so that's in kilometers to miles, so 86. 8600. So it's 53. What's that? It's really not that far off, really. But I'll notice it, because that's, 30 miles, I'll notice it. So, let's, because in Google Earth, so I just got it called measurement, and I got 5385. I'll do a print screen. $53.85. So now I got $53.85. Not that. It's pretty close now. But to do that, let's see. CAD. Because you're not even because here's the United States right here, alright? So, in that picture, you're cutting through the United States. So, yeah, not gonna happen. And you can't go along this, you know, around the arc circle here. And that's actually how you measure this, you know, with the projection. So, it's the ones going north and south, because there's a V. So the circles, you know, they just get bigger, so the distance around should be pretty good, but measuring north and south is where you'll come into trouble. And so, if we look at this, we'll just go clean, or get it here to the bottom. So that's looking straight down on it. We'll go to try to get the so it's kind of like the same view. Straight line, the meridian. Okay. And so that's what I get. I mean, it's pretty similar. So, to verify, well, we verified the distances. So now, we'll do some measuring real quick. That'll wrap it up. So I want to know the lat and long for some of these points. Make sure they're, you know, in the right position. Because maybe CAD, you know, didn't place them correctly. So let me do a 3-point. We'll just start at this. For this one over 3-point. So I got, so that's the meridian right there, that line. So that I measured. Yeah, degrees. So 8738.9. And so for so 0.5, I got 87. Well, I'll do a print screen. No one will believe me. So for the longitude, 8738.9. So 8738.9. Okay, matches. Now I need to measure from there. Let's see. There to here. So we'll go 3 point. So 41, 52, 44. So 41, 52. And then if you rounded that, it would be 44. So that one checks out. We'll do one more. Actually, I like to. It's kind of cool looking. Alright, so we'll just do maybe this first one. So the Empire State Building. And then we'll go ahead and do 3 point. Alright, so I got, for the north latitude, I got 40, 44, 55, and 73, 59, 8. And so 7. Properties. Flat screen. Okay, so So 73, 59, 8. So 73, 59, 8. So that checked out. So the latitude. So I got 40, 44, and 55. So I was off just a hair there. Should be. Well, that's like it's in the right position. And so I can measure up here too and get the same angles. I can tell you the drop. So I can do some pretty interesting things. Main thing I just wanted to show was the distances. And they come in the right spot. And they match the globe perfectly. Very good. And I do have the geoid or the ellipsoid, but don't really need it. I just need it for the so it's wider than it is tall. So you'll see I got the Earth sphere in blue and the ellipsoid in red. So that's why you see blue on the side. And I'll be red. You can tell that arc is just right on the surface too. So I'm gonna make this short because I could show a whole lot more. But